Good afternoon. My name is Rachel Grice, and my lesson will be over coding today. And I chose standard CSK 8 G6.6.1, which is 6th grade computer science standard for use of visual block-based or text-based programming language individually and collaboratively to solve level appropriate problems. With this, I have chosen a Scratch lesson that is Coding and Activity Overview Sandbox, Snowflake Drawing Nested Loops. The expected completion time for this project says 40 minutes, but teaching in the virtual environment, this lesson might take a little bit longer because I would have to explain to the students how to log in, as well as setting up their account and going through this slowly. I would want every student, no matter their level, whether they have an IEP for reading, an IEP for math, or such, to be able to do this. If my students had an IEP for reading, I would make sure that I showed them step by step, like I'm going to in this video, on what they needed to do to log in and what they needed to do to program in Scratch. If I had a student with an IEP for math or reading, I would create a video and work through some of these step by step to make sure that they understood what they needed to do. If it was reading, I would read the instructions verbally and have plenty of videos explaining what they needed to do. There's also videos on YouTube that work through many problems that you can do. If I had an advanced or proficient student that already knew block-based coding and wanted to code in Java or such, they could do lessons that I create in REPL.IT and actually present a code that has to work that they have written. So for this activity, our activity description is students will code Scratchy to draw a snowflake. Our objectives are students will be able to apply knowledge of the Scratch Pen tool through discussion with classmates and utilizing the feature in a coding project. Students will be able to understand and apply knowledge of nesting loops through discussion with classmates and utilizing the loop element in a coding project. Students will be able to recognize the Scratch element of events and motion by using the elements in a coding project. And for further understanding and knowledge of events and motion are developed later in lessons with other standards. So our lesson is split up with a table of contents of a prerequisite, which is understanding the Scratch environment, which is right here. What we would have to do is first have them set up an account. So they would go to Join Scratch. I, having taught K6 technology for 2 years, already have a Scratch account, so I will sign into mine, but they would have to join. It's fairly simple. They would just create them a username and a password, one that they will remember, hopefully, or write down so that they can remember. I had my students write it on a note card, and we kept it in a note card file per each class. But with them being at home, they can write it down and keep it in a binder or something at home. So when they get to this point, I would have to make sure that they went to create. But before I go to this step, I will let you know that for this lesson, I would need the Scratch website. I would make sure that I had all my standards and learning objectives listed on a slide, and we would go over that. Then I would have my website link for scratch.mit.edu listed on one and a link that they could click on and go to, and I would put it in a chat box. In this lesson, I also have exit tickets. So I would have all the exit tickets sent to them, and that way, as they finished, if they worked ahead or with me in class, I would send it to them, and they could answer the exit ticket as my test to see if they knew what we had learned. In the end, my final formative assessment is going to be that their that they've drawn their snowflake for this lesson, that they have coded it correctly and drawn their snowflake. And then I have a teacher printable copy of this lesson plan that I can also send to them that gives them step-by-step directions. In this lesson, we have vocabulary that needs to be learned, and I have an actual virtual word wall that I could share with them, and we would put these definitions in that word wall so that they could keep up with them. And I could also give them, as another assessment, a vocabulary test on the vocabulary that we have learned in each lesson. For this prerequisite lesson, we have program, which is an algorithm that can be coded into something that can be run by a machine. Computer programming is making sets of instructions to enable a computer to do a certain task. A loop is the action of doing something over and over again. And a nested loop is a loop inside of another loop. So, after I have my students create their Scratch account and log in, I am going to explain that this is a tool that teaches them to use drag and drop blocks and images as opposed to type code. These are drag and drop blocks that they will drag and drop to have do. With the drag and drop, which this is later in the lesson, but they have to have an event, and we'll get to that. So we are going to explore first the different parts of the Scratch platform. In the Scratch platform, we have the stage, which is the upper right square right here, where the output from the coding sequence will be displayed. The puzzle or game interactions will occur in this section. We also have the green flag and the stop sign button. The green flag and stop sign buttons in the upper left section of the stage will help the students in this project. As students build a project, they will learn to start a program by clicking on the green flag. They will stop the program by clicking on the red stop sign, just like when they are driving. The palette is over here to the left. On the palette, we have tabs for different programming elements, such as code, which is what we want him to do, the costumes, where we can change what Scratchy is wearing, or our person, because you can change the sprite. This one's name is Scratchy. Like in here, he's costume 2, here he is costume 1. Then we have the sounds. The sounds are the sounds it makes, or you can record. You can also make it fade in, reverse it, robot, faster, and then you can add sounds if you like. There's different ones. The scripts area, which is the middle of the screen, let me go back. The middle of the screen right here is called the scripts area. This area is where the student will build a program by dragging blocks from the tabs right here. The sprite list is down here. In the sprite list, sprites currently contained in the area are available for the project. The blue Choose Sprite button allows students to add or create new sprites to use. Each time a sprite is selected, the scripts area will change to show the code tied to that sprite. So whatever sprite we have right here will have code tied to it. So we will keep Scratchy for now. So that was all for procedure, for the prerequisite. We will start a little bit into procedure 1. So procedure 1 is setting up the pen tool. So we have some new blocks. The new block is under, well actually we go right here and we're going to choose pen to draw with your sprite. We can select our pen color, and we can also select to change pen size by. So to find the using coding blocks from the pen extension, we clicked the button down here. So these are used to draw paths on the stage, which the stage is over here. They also provide commands to change the pen size, color, shape, visibility, etc. Anytime the pen tool is used, these are the most common blocks used together: erase off, pen down, set pen color to, set pen size to. In this procedure, students will use 2 of the 4 blocks to establish the properties of the pen. The other 2 will be used in the next procedure. So after the prerequisite, I would have the students take the exit ticket. After each section, there is an exit ticket. Then I would do the formative assessment of having them turn in their finished project. I would interact with the students by first explaining the instructions, getting them logged in. Then I would show them a few steps on how to use Scratch. By the time we got to procedure 2, I would work with them and have a student explain. Then procedure 3 and challenge activity, I would have them do by themselves. And they do. I would also, for the individualized student data, would be them finishing the project by themselves and turning it in, and their exit tickets would be done on their own. For the differentiation, I would, if the student needed a little extra help with me reading the instructions to them, I would. If they needed me to work with them one-on-one going through the activity, I would. There's really no math in a lot of these lessons unless they're having to add or change the number of steps. There is reading, but like I said, I could have it read to them, give them lessons that are read to them. I could also do a video of going step by step. My son did a lot of these as well as I have, and I did it in my K6. I had a video going through it where I worked it step by step. How I know that they have successfully met the outcome is either their coding project that is finished that works, or in this case, it would be the printed snowflake, which is the success of the lesson as well. The learning experience of the students' engagement and the gradual release of the responsibility is that I show them the process of setting up their Scratch, how they join the website. Then they do that, and then I show them steps to work in Scratch, and they finish. The text and digital resources were, the text is the instructions going through it, which there's various different websites that you can use. So the websites are going to be all over the place. I will ensure that students engage appropriately in the lesson by working this through them and make sure that they are coding correctly. In the virtual classroom, I would have to make sure, maybe have somebody share their screen to make sure that they are working through the project. With coding virtually, it's probably a little harder, but they will have step-by-step lessons they have to do, tests that they have to take, and I will be able to see what they have done. I did it in the K6 environment. and it was pretty simple.